Hello and welcome to Math Zone African Motives. Today, we're going to dive into a powerful method for solving systems of linear equations called Cramer's rule. By the end of this tutorial, you will be able to solve for a specific variable in a system of equations using Cramer's rule. Let's look at the problem we'll be tackling. The question is, given the system of equations, a minus 3b plus c equals 4, 2a minus c equals minus 2, and 4a minus 3b equals 0. Solve the value of a using Cramer's rule. Before we begin, let's briefly review the formulas involved. Cramer's rule relies on calculating determinants. For a variable x, the value of x is the determinant of the matrix D sub x, divided by the determinant of the main matrix D. In our case, we need to find a, so the formula becomes a equals the determinant of D sub a, divided by the determinant of D. So to find our variable a, we will use the formula a equals the determinant of D sub a divided by the determinant of D. Our first and most important step is to prepare our equations by ensuring all variables are aligned in each equation. Notice our third equation is missing the variable c. Let's rewrite the system to be very clear. We'll use question marks to show where a variable is missing, indicating its coefficient is 0. Rewriting the system correctly gives us 1a minus 3b plus 1c equals 4, 2a plus 0b minus 1c equals minus 2, and 4a minus 3b plus 0c equals 0. This standard form is crucial for setting up our matrices. Now that our system is in standard form, we can build the two matrices we need, D and dA. First, let's create our coefficient matrix D. We'll highlight the coefficients of our variables, a, b, and c. The first column will be the coefficients of a, which are 1, 2, and 4. The second column will be the coefficients of b, which are minus 3, 0, and minus 3. And the third column will be the coefficients of c, which are 1, minus 1, and 0. Putting this all together, our matrix D is column 1, 1, 2, 4, column 2, minus 3, 0, minus 3, and column 3, 1, minus 1, 0. Next, let's construct the matrix D sub A. For D sub A, we replace the column of A coefficients in matrix D with the column of constants from our system. The constants are the numbers on the right side of the equations. So the first column of D sub A will be 4, minus 2, and 0. The other columns remain the same as in D. Our matrix D sub A is column 1, 4, minus 2, 0. Column 2, minus 3, 0, minus 3, and column 3, 1, minus 1, 0. Now we have our two matrices, D and D sub A, ready for determinant calculation. The next step is to calculate the determinant of matrix D. Here is our matrix D. To find its determinant, we will use cofactor expansion along the second row because it contains a 0, which simplifies our calculation. The formula for cofactor expansion is the sum of each element in the row or column times its cofactor. This means we take each element, multiply it by its sign, plus or minus, and then multiply that by the determinant of the submatrix that remains when we cover the element's row and column. The alternating sign pattern starts with a plus. So for the second row, the signs are minus, plus, minus. Let's expand along row 2. We have minus 2 times the determinant of the submatrix, minus 3, 1, minus 3, 0, plus 0 times the determinant of 1, 1, 4, 0, minus negative 1 times the determinant of 1, minus 3, 4, minus 3. Now we calculate these 2 by 2 determinants. A 2 by 2 determinant is found by multiplying the diagonal elements and subtracting. For the first part, it's negative 2 times the quantity minus 3 times 0, minus 1 times negative 3. For the second part, because we are multiplying by 0, the whole term becomes 0. For the third part, it's plus 1 times the quantity 1 times negative 3 minus negative 3 times 4. Simplifying this gives us minus 2 times 3 plus 1 times 9. This equals minus 6 plus 9, which is 3. So the determinant of D is 3. Next, we will calculate the determinant of the matrix D sub A. Here is our matrix D sub A. Again, we will use cofactor expansion along the second row to take advantage of the 0. Just like before, the sign pattern for the second row is minus, plus, minus. Expanding along row 2, we get minus negative 2 times the determinant of the submatrix, minus 3, 1, minus 3, 0, plus 0 times the determinant of 4, 1, 0, 0, minus negative 1 times the determinant of 4 minus 3, 0, minus 3. Now we simplify. This becomes 2 times the quantity minus 3 times 0, minus 1 times negative 3, plus 1 times the quantity 4 times negative 3, minus negative 3 times 0. Calculating the determinants inside the brackets, we get 2 times 3 plus 1 times negative 12. This simplifies to 6 minus 12, which equals negative 6. So the determinant of d sub a is negative 6. We've calculated the two determinants we need. We are now ready to find the value of a. Let's recap our results. The determinant of d is 3. The determinant of d sub a is minus 6. Now we use the Cramer's rule formula for a. The formula is a equals determinant of d sub a divided by determinant of d. We substitute our values, getting a equals minus 6 divided by 3. This simplifies to a equals negative 2. So the value of a in this system of equations is negative 2. Let's quickly check this with the provided memo. The memo also finds a equals negative 2, so our answer is correct. The verified final answer is a equals negative 2. Let's quickly review what we've accomplished in this tutorial. Our goal was to solve for a variable using Cramer's rule. We started by arranging our equations into a standard form, making sure to include 0 coefficients for any missing variables. Next, we constructed the coefficient matrix D and the modified matrix D sub A, where the A column was replaced with the constants. After that, we calculated the determinants of both D and D sub A, using cofactor expansion to simplify our work. Finally, we applied the Cramer's rule formula, dividing the determinant of d sub a by the determinant of d to find our answer. This process allowed us to successfully solve for the value of a. That wraps up our tutorial on Cramer's rule for today. I hope this step-by-step guide was clear and helpful. Thank you for watching. Don't forget to subscribe for more tutorials from Math Zone African Motives. See you in the next video.